How's it going, everyone? Welcome, Eulier Gonzalez here, and today I want to finally explore is the data fetching sections, which the situation of this is how do you fetch now documents from another computers and somehow render that. So for that, here, Josh Komewa, a software engineer that previously worked at Khan Academy, one of the ever allegedly large React code base use, where this now acts as a sidekick for your learning. And he now show here is several modules, right? So the recap for this context is that, hey, first we need to know what React is, why we even care about React, why React exists, and what React allows us to. So React exists because Facebook back then, 2007, 6, they have a particular problem of updating a piece of user interface like this that I'm highlighting, and somehow is store this piece of information and make it easy for that to maintain. So the TLDR of the React is that, hey, let's go to now is centralize is the piece of the state of that information that is shared across different components. Hold that into JavaScript, right? So let now the language store that information on disk for us, and any time that we need to update is the UI, React behind the scene is going to trigger that state updates that is going to show relevant that state of React, right? The TLDR is now the UI piece of information live on the JavaScript. There is something called Hotwire, right? From Ruby and Rails, where this takes now a different approach of how you can store the state of your application, particularly the document here, or your UI. And in terms of UI, you have now things like the HTML. I don't know why, but the living standard, of the HTML, which is something that describes how the document will be used, who is going to implement those documents, and when this document is going to be used to render that, and the anatomy of this this document, which is on the section 4 that describes the element of the HTML. So the HTML or the metadata or the sections that which is in order to organize this document and how it's going to look like. The grouping context, for example, like paragraph. It's interesting that they don't mention here sections or H1, but in any case. So, but again, grouping context. So paragraph, another list, menus, data lists, which is something using inputs, main, search, diff. The other is text level semantics, how the text is going to be look like. Is this a ball, or this is an anchor, or is this now some code? For example, like with pre to provide some formats like the pre, or let me. That's interesting. So italic, bold, or strong, right? Links is another element here, and the entire anatomy of the links and how you can use the API of links, right? There are content that you want to edit, all right, and then you have now elements to do that, or content that you want to embed it. For example, like image, pictures, iFriend, which is another browser, is another document here, video, drag elements, right? Tabular data, and also is the long and sometimes annoying form. So additional to form, right, is some of these interactive elements. Some of them might be quite new to ourselves, like details and summaries. Dialogue is another one. The scripting, which is this is here is describing, hey, what are this piece of information is going to do, the scripting section, and some of the custom element, which is the ability that you have to create your own particular elements. So there are also another sections here like common idioms, disable elements, and matching HTML. But the TLDR is that with this thing called Hotwire, the idea is that, and I mention here because this is something that Ruby on Rails application actually using behind the scenes, where instead now is the source of truth live on the JavaScript land. So now as an object, so now the source of truth of that particular element, the HTML elements, now we live in the elements as a data attributes, right? I'm gonna make a quick pause here real quick. So, well, I know that this is quite an oversimplification of what the Hotwire is at the end of the day, but the thing here is that with that huge introduction of the React ecosystems and how do we get here. So in the case of the model of or the course created by Josh Kummerer, and the first model we look at the anatomy of the React, right? This, the way of how you can build React from scratch, what React is at the end of the day, which is a JavaScript library, and then how you can create your own React by wrapping now an HTML element in a nice little wrapper and provide certain additional features that will describe is the UI. Those things that describe is the UI is, for example, hey, it will have a key, this will have a children's, and this will have now props that is going to receive. And because we are now building user interface in this way, instead of using the HTML and CSS and JavaScript, the traditional way to build that application, now with React, this actually behave in this way, and there is now a way to building these applications. So the anatomy of these React applications is that you will have now an index, or in other words, the entry point of your application, which is the index.ts or JavaScript JS. Here when you're going to mount or load a JavaScript React function, and then you will have now is the entry point of your React application, which is the app.js or tx. Here's when you add things like React specific. So like, hey, I want to now add a new theme or add some context where this context will now keep track of information like the browser navigation or transitions. Here's when you add now, for example, your CSS. And then you have now your models where you're going to describe is how these components will look like. So this is just the model of one, and also is looking at the most common thing that you do with React, which is rendering a list of elements, conditionally rendering elements, and then create now form on top of that. And because form is a way of how you can now allow the user to interact with your document, with your application, right? So we need to look at how is this model works, known as the event model or the DOM living standard, which describe is the certain interruptions that can happen to prevent some actions or some events, and also the way how the document is organized into an object like model, right? And how now the event is being triggered here, or how now is that the browser or this client that implement is this way to render documents and interact with what is the particular model to that, the event model. And in that model, the way to detect those events from the user is in two ways. In plain vanilla JavaScript or HTML, is that whether you add now an event listener to that particular element, and when something happens, you're gonna trigger that function, or you directly apply the function call in that event attribute at the element, right? But in the case of React, it's say no, I'm not gonna do that. You're gonna give it to me as a function that you want me to call, and behind the scenes I'm gonna call that function for you on the handler, right? So this is part of the React basics. And when you want to now starting to compose your user interface to build now is websites and pages and applications, products, and right. First, I look at how to do that by using some of these specific behaviors that React come out, which is the state. What the state is, it allows to store some piece of information behind the scenes, and this informations is something that will persist in our application unless we refresh the app, right? This is why in the beginning of this video I start to describe that the state of the UI, what this piece of information will live. In the case of React, it will live on JavaScript land, and in the context of another tool, which is for Ruby and Ruby applications, right? You will have now is the hot wire, which the state of the application now live on the server, and you can add that to the HTML element as a data attribute and update that using is a particularly library called Turbo that go beyond of today's discussion, but I just want to point that out, that specific thing that is relevant. Now, because as you build your applications, and the way how you do that in React is by passing up props to children, and it's in this fashion that allow you to is receive those props or creating your own particular states, right? These states or props is a way of how you can first pass data or and remember piece of information. Things like states allow you to remember that piece of data. And because as you starting to make that piece of information available, and since we are now creating this tree of elements, pretty much like the DOM, the document object model, is creating now a tree of elements, all right? So depending on which position in the tree that state live, is going to be accessible to that to the children components if you pass down that piece of information. This is known as the prop drilling, because this process is something that it involves quite so this act like a pipe in one direction where you pass now your information is top down, right? The problem with that is that it is easy for us to manage is the state of the application in a small pipe rather than increase the dimension of the pipe, right? So because now more things can pass through that. So because of that, now we have this thing called context. something that we're going to see that later on in further videos. But as you started to understand this and the notion of component instance and rendering, right? So we have now the ability to use additional behaviors that React gave us to, such as not only use state to store some piece of information, but also use ref, use ID, hooks, or hooks like side effects hook, like use effect. What is the life cycle of these hooks? What this allows us to do, right? And also create our own particular hooks when it comes to describe is this user interfaces. Now, and the reason of talking about is this custom hook is because this will allow us to now separate the concerns between the UI and the logic, right? So as you started to create more ambitious applications, not only blogs or landing page, but also now gaming application or trading apps, or now SaaS applications, right? Or back office apps. Now it becomes a problem of how do you handle is this piece of information here, and where do you handle that, and how you do that. So whether it's on the client or this is on the server, and if this is on the client, which application you can build with this. So landing page or blogs, or even server, or even heavy interactive applications like gaming or trading, right? So when the state of the application must live is on the client, right? Because you don't want any delay in that. But if the piece of information now live, but instead of trading apps locally, I prefer to use this in gaming, where the entire state of the app live on the game. But on SaaS applications, right? Now the state live on the database, and you need to somehow, connect to that. And there is a couple problems that come up here. But here's the thing: there's 3 tiers of products that you can build. When you're building landing page or blog, you rarely rely on some global piece of information, some global state. And when you're building now applications that are heavy client-side applications like gaming, so now you need to somehow is to keep track of all of those state changes. So that's what we have now, Redux, for example, or Substand, or any other state library management, right? So in the case of Vue, you have things like Vuex or Pinia. But now, in the context of the applications where the state live on the server, like SaaS or back office apps, so now there is a different set of problems. At first, how do you keep in sync the data in the client and the server? So in other words, how you get rid of the stale data, or how you can now keep up data updated, how you can now fetch a small amount of information, how you can catch that response in case you need to, and how you paginate, and how you now preemptively prevent some of this, or how you can at some point is preemptively fetch some resource before even the user actually clicks on that. So those kind of problems, which now are part of the server-side rendering applications, are something that now is the reason why actually looking at the data fetching here. So in other videos I describe is how to set up an HTTP server from scratch, looking at the white paper, HTTP 0.9, 1.0 and 1.1, So here I'm going to look at the data fetching, particularly on the React applications. So there is a couple things that you can do with your in this documents, right? So for example, like search engines are a huge database. Let you filter billions of entry to find the most suitable results. The others are chat applications like Slack. Let us send and receive message stores in database. Or social media networks, which provide feeds pulled from a database and let us interact with that. There's additional applications like Exchange app, right? But in this lesson, we're gonna see how to send network requests in React context. So this is the tool of choice, right? So there is a huge universe of tools here that you can use to that. And first you need to understand the basics of this way to talk to remote applications. So again, the TLDR of that is when two programs, for example, now like in the case of the HTTP server or the web server, like the client, like the browser, in the server, right? When two applications needs to communicate, where they don't live locally, they live on different computers. So now you rely on this thing called TCP and IP. So the TCP, what it does is a protocol that guarantees that the quality of that information reach to its destination, right? And it uses now something called a socket. And a socket is just an abstraction of the OS that say, I want to now describe how the communication between two processes or two programs happens, right? Whether it's you now read what's going on or you can write there, okay? So this socket, all right, is what allows now this communication between this particular computer, which in my case it is running in the client, and communicate with the application, with the computer that store this document that I can see here, right? So this is actually part of the at the OS level. But here, and because now, as I mentioned before, React is something that lives on the JavaScript land. In JavaScript is something that is on top of the browser, and the browser is an application that is reading in C or on this high-level language that allow us is to write is applications like operating systems, right? Which is a compiler at the end of the day. And this compiler or this compiled language in the context of the application that is relevant here, Chrome or any other browser is the client side, right? That allow is the client application that allows us to communicate and fetch resource. In this case, documents or any additional resource out there. So now with this document here, right? There is a couple things that we need to deal at least in the JavaScript, because the question is, how now do we actually synchronize with things that happens out of sync, right? Or things that happens over time, which is known as concurrency, as one. And how that we now is coordinate that in a way that when you, for example, send multiple requests, it arrive in order, all right? And if something went wrong, we want to somehow receive an error for that. And how you make that coordination when you're writing your applications to look like synchronous, right? And well, what are the things that allow you to fetch some of this research here? This is why we'll look at the prerequisite of synchronous versus asynchronous code in JavaScript, because at the end of the day, this is what now this C program or C++ program called the browser actually use as an input, right? JavaScript as an input. It's going to pass through a JavaScript engine, and then it's going to execute those statements. Promise, which is the way of how you can handling is this asynchronicity, which is a wrap of so promise comes from the if I recall this great, promise comes from the mathematical way to I would like to even now look at the paper here. I'll be right back. So now this is actually looking at the promise object on the spec, the ECMAScript, and here this is part of the control abstract objects. So this is just a fancy word to say, hey, this section is going to describe the specific behavior when you need to have some sort of control operations. Control operations like, hey, how can I iterate to something, all right? How can I wait for something, right? Known as looping or asynchronous programming here. And here is describing is what the thing is all about. But again, the TLDR is that this is now is a placeholders to give you the result of a deferred or possibly asynchronous computation. And I'm not going to lose myself into that because this is part of the prerequisite, but it's important for you to understand now synchronous and asynchronous code, that the other is promise. How can we now here in JavaScript solve that particular problem that we have as a way to solve this asynchronous computation, or this computation that will be resolved at some point in future. So for example is, how do you now is in the case of distributed system wait for something to be done, particularly in the case of the HTTP, which is the protocol that describes this request and response, where here it say this is how now we're going to fetch data from this computer where that document live in a different computer, right? So this is the protocol that we're going to use behind the scenes, and the protocol follow is now initially in the version 0.9 is it just was useful to fetch research, and it assumed that all research are documents. But now as the web evolves and grows in its complexity and in its needs, in the 1.0 it say, hey, you know what, it is also important to have a structure of how this message will be used as a way to now is describe this request and the response, right? Additionally, we want to know how can you add specific headers to not only fetch documents but also additional documents, and they rely on the MIME type, which is, hey, instead of fetching only .html documents, I want to also fetch is image or .zip files or any of the different file extensions that exist on the internet. So this is what the HTTP 1.0 allowed to, and also additionally is the ability to define now catch So you can now set a server to allow you to define a catch by adding catching or by adding a catch for that response, right? So how you can catch those messages and also add intermediaries between your computer and the destination, known as proxies or gateway, right? And the difference between is proxy, it allows you to now interact with request and response, usually sits closer to the server, right? Where now gateways is something that is still developing my intuition around and reading about that. But yes, that's something that I'm going to explain that later on. And well, also is the basic HTTP methods, right? So you have now get, you have post, you put, delete options, and also the new one, which is search, which is I mean, this new method has been added 2 months ago, and the other is fetch basics, right? So when you need to run or when you need to request documents using the HTTP protocol like this, right? So when you look at the fetch here, this specific API or spec described is the process of so defining a standard of request and response and process them and the process that binds them, like fetching, right? So it just, and a standard way to describe is this HTTP response at the end of the day, right? So it relies on all of this kind of stuff. This is not exclusively for the JavaScript API, right? Which exposes most of the networking functionality at a fair level extractions, right? But there are other places on the client side, application like the browser, where they need to fetch some resource. So image or script elements, or for example CSS cursor or list image, and navigators and beacons, and also self-import, and each one of them has their own particular way to fetch that those resources, right? So here this spec say no, let's going to standardize this, all right, and also allow to or to expose now an API where we can do this networked operations, right? So this is part of the fetch, this is the input and the init, right? He is describing is what the thing is doing behind the scenes. We can look also is a more friendly way to actually define that. Is like, hey, what is a resource? And by resource is, well, the URL, all right? Here is describing as this, a string or any other object with a stringify, including a URL object, right? And the other is the request as well. So this step is now a resource and followed by the options, object containing any custom setting that you want to apply to that request. And here are some of the couple examples here, right? This is my request. It's interesting because you can use now an object called request or response. We traditionally don't ever use this, and to me it's quite revealing, quite interesting. Yeah, it is quite interesting that we barely use this, but that request object exists. All right, so this is what the fetch API it is, right? It's a promise resolved to the response object representing the response of your request. So the fetch promise only rejects when a request fails, for example, because of a badly formed request URL or a network error. So a fetch promise does not reject if the server responds with HTTP status code that indicates error like 404 or 505. Instead, a .then handler must check the response.ok and or the response.status. So this is more like a request API for network error or for badly formed request URL, but not for errors thrown by the server. All right. So, so with that, right? So this is also how you can define here, right? Hey, this is now a headers. I want to set this different header. This is the option. Putting now here as part of the request, and this is what they recommend you to go with, right? That you provide that. You can also as part of the resource define the request object, which is something that most of the time we do here, right? So here on the this is part of the URI and this is part of the option, right? So when you now specify is more of the options that you can describe, right? So far so good, because now with that, okay, finally we're going to look at the fetching on event, fetching on mount, a couple exercise, and a sync effect gotcha. I'll do that in the next video, so I'll be right back. All right, and we are back. So let's get into this, right? So data fetching on event. So if you have ever built a developer portfolio for yourself, odds are you are implementing a contact form, and these forms are all over the internet. And let's see how we can implement one, right? I actually know how to do that, but let's see how you describe that in React.
Building a contact form. And I've already done some of the work in terms of managing the state. So I have these two state variables and they're each controlling their respective form input. Mm-hmm. But when I submit the form, we see a full page reload. Not really what we want to be doing, right? The default behavior for forms is to make a request to the current page, whereas we want to direct that request to a specific API endpoint. So I'm going to start by adding an onSubmit handler and assigning a handle submit function. And we'll define that function right above. It'll receive the event, and the first thing I'm going to do is call event.prevent default.
Why prevent default? Because this is something that is the behavior by default, that when you submit the form, it will trigger a re-render. So we don't want that.
We'll stop that default behavior where the form submits to itself, but it does mean that I've essentially broken my form, because now nothing actually happens when I submit it. Well, let's do something about that using the fetch method. And I've provided the endpoint that we're going to use with my test API, so I'll make a fetch request to that. I have to supply a couple more pieces of information, including the HTTP method, which is supposed to be post. That's the method I chose for this endpoint, which I think makes sense because we're creating a new thing. In this case, the thing is a message. And I also need to supply the data itself, so the customer or the user's email address and the message that they're sending. So I'll pass along email and message. Now there is a very common gotcha here, which is you're not actually allowed to send objects over the network, right? It has to be a string. You can't send arrays or objects or functions. It's just not something that the network supports. And if we don't do anything at all, the browser is going to try and stringify this object, but it doesn't do a very good job. And you've maybe seen this before. Like if I have an object which is equal to, let's say, hi 5, if I call o.toString, I get a very unhelpful string.
It's just going to try to browser is going to exactly. You see, again, because this is part of the JavaScript stuff, is coercion. How you're going to transform is this into another type, particularly the object into an string. So this is now have an internal table that when he detects any object is going to now transform that or parse specifically is going to coerce that value into this value here as object.
Of object, whereas if I use JSON.stringify, I get a much nicer string representation of that object. And
in other words, hey, allow me to recreate a string from this JSON.
then the backend can essentially parse this string back into an object. So I'm going to say JSON.stringify and pass.
JSON.stringify is a method that is from the ECMAScript, right? And I want to make a quick recap here of that, because I do find that's very important, at least to know where all of these things come from. Part of the global fundamental objects, text processing, structured data, key collection, index collection, text processing, the global object. That's interesting. It is on the global object 19.4. Okay, there you got it. The global objects. So like atomic, JSON, math, and reflect, right? So this is something that now is the engine, the library provide to us by default, right? So if you look at that and the JSON structured data, the JSON object is just as it is, right? The JSON data interchange format is defined in the ECMA 404. And the JSON interchange format using this specification is exactly that described by the ECMA 404, confirming the implementation of JSON .parse and JSON.stringify, right? So stuff that come from the global object as it is, right? And part of the global object you have properties. So global this, infinity, nan, and undefined. You have now functions property that you can have access to. Like, for example, eval is finite, is a nan, parse float, parse int, URI handler functions. And URI handler function is like, hey, let me take this URI and encode it or decode it, right? And it's actually describing is that. The other is construction property of global objects. So now you can have access to all of the different functionality that the language provides for us, right? And as you can see, it's a long list, but it's not that big. And it's describing is this, aggregate error, array buffer, big int, booleans, data view, date, disposable stack, error, finalization register, float, function, integer, integer 8 arrays, iterator, map, number, object. So it is a mix between the primitive values, the object values, data or custom built-in APIs like JSON and map or math API, as well as some additionals that are relevant for the asynchronous programming, control flow like iteration, right? Regular expression and all of this, right? So again, this is just specifically to the JavaScript engine. So that's fine. Let's continue to look at this.
This object. Now when I run this code, it makes the request Fetch is promise-based, which means if I want to do something with the request, I'd have to write .then, get the response, turn it into JSON, and then another .then to get the actual. I don't want to do any of that. So instead, I'm going to use the async await keywords. So I'm going to make this an async function, and I'm going to await the result of this fetch and capture it in a response variable. Then, to get the actual body of the response, I'm going to say response.json, and I also have to await this, which always, I think it catches everybody off guard that if I've already waited for the network request to finish and I have the response, why do I have to await this? And the short answer is that we don't necessarily know that we have the raw content yet. It could be streaming, for example, in which case it comes over multiple parts. Not the case in this case, but we need to structure our code in a way that can accept any case, and so this is the way to do it. If I then log this JSON, we can see what we get back from the server. I submit the form. If I go check the console, hey, look at that. I see an object. I have an OK property, which is set to true. And then I see that it's reflecting the data that I sent, so I can confirm that it received the data I wanted it to receive. And so all of this looks good, right? We see that the network request is succeeding, but it's not really the best user experience. I submit the form, and maybe it worked. We really have no idea unless we expect users to go digging into the developer tools, which is obviously an unreasonable expectation. So even though we have successfully completed the network request, our work is really just beginning, and we're going to tackle that in the next part of this lesson. So we're building a content.
All right. So I'll be right back. Make a quick pause here. All right, and we are back. So, got it. Okay, so in this video, we see how to send data to our backend API using fetch, or in other words, how to request data from the API. We saw how to send a post request, how to stringify the body, and how to validate that we receive the corresponding response from the server. But really, this implementation is not yet complete. We need to update the UI so that the user knows what's happening at all times. And here's a sample from the video above, right? So how you can do this, right? The loading success and error status. When submitting network requests, we want to update the UI to indicate 3 different status. So loading, success, and error. So in this video below, I'll show you how I have implemented these statuses and updating the UI accordingly, but I encourage you to give it a shot yourself using the playground above. Feel free to structure things however you wish, updating the UI in whichever way you feel make the most sense. So my particular approach is that since this is the 3 state that I want to handle, right? Loading, success, and error. So I can define now, because this is not TypeScript, but it's JavaScript. So I can define now some enum or bag of constants that say, hey, this is network status, all right? And this network status, initially it'll be is loading. But this also can be is in this 4 states. It can be idle, waiting for something. It can be loading. It can be success, or it can be an error. That's just all the possible state that this can have, right? So this is loading, right? I prefer to use now loading here. So, yeah. I prefer to use this now as lowercase. All right, so there you got it. Now, how you can represent this? So, what I can easily say here is that once I get all of this piece of information from this input, right, and it is form and so on and so forth, right? Well, when I call this response, particularly on here, let me actually define this outside of this, right? I want to now set the network status In this case, this will be now a variable that can edit its value. All right, to loading. Right. So let this network status to loading. All right, and if, for example, now on the JSON I receive now an OK for that, then I'm gonna say, okay, the network status is equal to success, right? If not, right, then the network status, right? If not, then the network status, it will be now on error, right? So there's something wrong with that. And that'll be pretty much that, right? So now here what I can say is to when that happens, okay, I can now wrap this entire form into this and say, hey, if the network, or just for the sake of the example here, just to say something like this, yeah, we're gonna let me add this here and say, hey, if the network status, I can initialize this as idle, right? So if the network status is loading, all right. Exactly. So let's go to evaluate this statement, right? So if the network status is loading, okay, give me a second. So here's what I did, right? I just want to avoid you to look at what I done in my process. So what I did is just to say, hey, let me now wrap this into a try and catch error, okay? And when something is good, you say, hey, okay, good, success, you did it. Another way to handle this is to say, hey, let me now do this like this, or just like that. And for that, well, you're going to cover is what to do. for that. So you can say is, hey, instead of actually wrapping this into something like the negate of a JSON, I can wrap this into, but again, like go beyond of today's video. I just want to focus is on this basic stuff here to say, hey, if this is okay, so you must send the okay in the JSON as 200, right? Otherwise, well, there's some network error, something went wrong, and you want to be more explicit about what went wrong, right? Let's say you say, hey, well, I want to now describe is the message here, right, or the status, okay? So you can have access to that and show that as it is, right? Here is going to capture when there is a network issue or where there is a malformed URL, right? Again, this is very specific to the fetch API. Now, so that's good, that's great. And now, right, so you can see, hey, if I submit something here, say, hello world, right, submit that. That's interesting. That I didn't show is the loading message. With it should be. With it should be, right? So if I submit that again, that's interesting. If I rewrite that again here and try to do this, I think it gets stuck. Hello world. As it is, I submit. Yeah, it's like somehow it gets stuck here. Yeah, somehow it gets stuck here. Let me see if there are any errors in the console. No, it doesn't. I think that is a playground. Give me a second here. I'll be right back. So, as you can see here, moving forward, I define now a state that are persisting across renders. So an initialize is the state of the network status here, like loading, but at the beginning I want to make this idle. So anytime that you submit, or the user submit the form, well, I want to now set this initial state here for the network and the network message, run or fetching operation, in this case by sending an HTTP post to say, hey, let me now send this piece of information as a stream, so on the other side it receives that. And when when the OS detect those incoming strings of bytes, it's gonna pass through the proper socket, which is these abstractions that allow you to programs communicate and share information, right? There are several type of sockets. The one that is relevant is how do you do that? For example, in programs that use TCP or over the internet, right? So now when you receive these streams of bytes from the OS, it is up to the client, in this case the browser, to decode those bytes into the proper HTTP response, that it can be, not only that it can take some amount of time to recreate that HTTP response, but also the server can stream data in that response. So that's why we have to wait for that. And then you can print that out, right? Here I'm using is the JSON.ok. It's a very silly example here. You can use is the negation for that. Later on we're gonna see that that's better. And here actually set the status and the message. and well, of course, clear up the entries as it is, right? And here we define now is a fragment here to wrap is sibling HTML elements like the form, and also is the additional status message that we want to send, right? And with something, and when you submit that piece of information, you receive that, which was what I did in a previous exercise. But I can do something like say hola gmail.com and say hey, right? You submit that, right? And then you now say their message responses. They say great, right? So you receive that piece of information from the server, and now you understand what's happening there. So let me take a look at this particularly video where Josh described how he did it. Right?
So the first thing I'm going to do is I'm going to create a new status state variable. And the idea is that this variable is going to tell us how things are going at any moment in time for every snapshot that we render of this component. And it starts life as idle, which is the status where they're entering their data in the form, they haven't submitted it yet. Once
and I want to make and I want to take some notes here, because the way he described that to me is very, very precise. The word he used for that. So here's some data fetching here, diggy, fetching on events, right? Where we are now, right now, right? So he mentioned something like this.
So the first thing I'm going to do is I'm going to create a new status state variable. And the idea is that this variable is going to tell us how things are going at any moment in time for every snapshot that we render of this component.
So here is our basic example here. So we create, so so if you had created a basic portfolio, odds are that you have a contact form. So here we have an example, right? Like this. So this is our example. All right. So the relevant part that Josh mentioned here is that in the context
So the first thing I'm going to do is I'm going to create a new status state variable. And the idea is that this variable is going to tell us how things are going at any moment in time for every snapshot that we render of this.
Mm-hmm. So the idea is to store a variable called network status. Mm-hmm. So the idea is to store a variable called network status, where we can preserve is a snapshot.
How things are going at any moment in time for every.
Okay. So it tell us how things are going. Are going in any moment in time, for every render, which is the contact form component.
Every snapshot that we render of this component. And it starts life as idle, which is the status where they're entering their data in.
So,
in the form, they haven't submitted it yet. Once they submit it, it's going to flip to loading, and then once the server responds, it'll either be success or it'll be error. These are the 4 states that I find myself using over and over and over again because they tackle pretty much any network request in terms of the things that can happen. And when they submit the form, I'm going to set the status to loading, and I'm doing this right away, like even before I've started the network request. Then the network request will take some amount of time to happen, and then afterwards I can choose whether it's a success or an error. But how do I tell the difference? I think a lot of developers expect that if the request fails, that we'll throw an exception. So maybe I can wrap this whole thing in a try catch, and that way when it throws the exception, I can catch it and do my status updates in here. But it actually doesn't work that way. Assuming that it is the server responding with an unhappy status code, like maybe a 404 or a 500, that doesn't actually produce an exception on the front end. It means that the response will have a different status, and it means that the JSON will be different, but everything will continue running smoothly. And so one option is I could check response.status, right? This will be a number. It should be 200 if everything went well, 400 and something if it was a client error, like something that I submitted that was wrong, 500 and something if it was a server error, so I submitted things right, but something's happening on the server, maybe it's on fire. But there's also 300 series statuses where it's a redirection, where it's still valid. And then there's the case where maybe the backend hasn't used status codes correctly. And so in my experience, this is like a good idea in theory, but in practice, I prefer to check the response itself, right? The data that I receive from the server. And so if I submit this form, we can get a preview of what that data looks like. And I see that I have an OK property, which is set to true. This is how I'm going to tell if the response is valid or not. So I'm going to say if json.ok, and in that case, I'm going to set the status to success. Otherwise, if it's anything else, I'll set the status to error. And so with these 3 calls done, we now have a status variable that accurately reflects where we are with this submission, and now we can start using it in our UI. And I'm going to start by adding the disabled attribute to inputs if the status is equal to loading. And I'm going to do the same thing for the text area, and even for the button. Looks like we've gotten stuck in the loading state thanks to a hot reloader update, but if I refresh the page and try this again, we see that the moment I submit the form, everything grays out until the response completes and then it becomes valid again. I like to disable inputs on submit because it stops the user from accidentally double-clicking the button and making multiple submissions. It also means they can't edit their field while we're in the process of submitting it because any edits they make wouldn't be received by the backend. But I don't think it's enough on its own, because it is a bit confusing. Like, what does it mean that they've been disabled? So I'm also going to change the text in the button. And I'm going to say if the status is equal to loading, then I'm going to make the text submitting with a little ellipsis. Otherwise, it'll stay as submit. And so now when I submit the form, we see the text changes. We could also put a spinner in this case. That would also be a good idea, as long as we make sure that the text is still there for people using screen readers. But overall, I'm happy with this as a loading state. What about the success state? What do we do if the request resolves successfully? And really, it depends on what we want the user experience to be. There's several valid options. One could be that we return something else entirely. So if the status is equal to success, then we don't return a form that they've already filled in. We return a paragraph with the text message sent. And so now, if I try to fill in this form and submit it, we get our loading state, and then at the end, we see message sent. Obviously, we would want the designer to help with this, like it does feel a little bit too minimal, but this is the fundamental idea with the logic. We check and see if it was successful, and then we render something else. But what if we want to let the user send multiple messages? Well, in that case, I'm going to take this paragraph, and I'm not going to return it as a separate thing. I'm going to include it at the bottom of the form if the status is success. That way, they can submit the form, see the loading state, see that it was successful, but continue to send additional messages. And I do see now it would be nice if the message erased. I think it makes sense to keep the email address because presumably this is the user telling the website administrator how to contact them, and that doesn't change. But if I want to send multiple messages, it would be nice if the message box emptied itself. And so I'm going to update when we set the status to success to also set the message to an empty string. That way I submit the form, and once it's successful, I see that the box has been cleared for me to send another message. Now in terms of error states, to make it easier to test, my endpoint with this test API I've created supports passing a query parameter called simulated error. And if I set that to true and I submit the form, we're going to wind up in an error state. And if I pop open the DevTools and go over to the Network tab and submit it again, we see the request start and the request throw a 500 error. And if I look at the response, I see that I still get a JSON object that has this error text. I wanted to make sure to include the simulated error information so you can always tell the difference between like it doing what it's supposed to and returning a simulated error versus it having a real error because something is wrong. So you can always check the response. You could also console.log the JSON that we get back, which actually I am doing, so I could have showed it to you there. We get this data back so we can tell if the error is legitimate or not. And so we are setting the status to error, but we're not using that status anywhere. And again, this is something that is really going to vary depending on the application. I think in this case, I'm going to duplicate this paragraph, but for the error status, and change the text to something went wrong. We could get really granular with errors and include the error message from the server and highlight the field responsible for the error. But I feel like nowadays, because we have such rich client-side validation, like if I try to submit this form with a required field that's been left blank, the browser will tell me about that. And if I try to submit an invalid email, the browser tells me about that as well. So as long as I use the required attribute and make sure to set my types correctly, and use all the other validation things we have access to, like min length, we don't have to implement a bunch of custom logic. We can rely on the browser itself. Now, we generally do want to duplicate that logic on the back end because it's easy for users to circumvent this logic. They can change the HTML. But if someone is trying to hack our system, I don't feel like they deserve really nice and proper error messages. So like that's no problem for me. But yes, as I say, right, the actual UI we render will vary depending on our application and what we want the user experience to be, but the strategy of having a status that always reflects the current state of the current snapshot, this strategy is solid.
So now he's describing the entire process of how you can now is using forms, submit a form in the React way, right? So in the video above, we touch at HTML validation, and you can learn more about the constraint validation, or redirect to the HTML living standard, which I prefer to go with. We also touch an HTTP status code, so you can learn more about the HTTP status code. Again, I prefer to look at the HTTP white paper 1.1 or 1.0, where it established all of this status code. And ultimately, that is the playbox. Right, so catching unexpected errors here. So in the example above, we're handling expected errors by checking the value JSON response, but we're not handling unexpected errors. For example, if the server is down, the whole thing will throw an error. To guard against this case, we should wrap the request in a try and catch error. Right. So again, here we're saying, hey, if we are not able to communicate with the server, or if the server is down, so we need to also is handle that specific case, which is why I use now try catch in my example. So that'll be marked as complete, and then move on to the next topic, which is fetching on mount, and I'm going to leave this as it is. So that'll be all for today's video. Take care. Bye bye.